Hey guys, and welcome to this video tutorial series in which you will be learning about how to program MSP series microcontrollers. So it will be a series of videos in which you will learn various tricks on various ways to program the various peripherals of the microcontrollers my MSP type, and mostly I'll teach you on like to code in the microcontroller through register set coding, so that you don't need any external library. So the first tutorial in this series will be on how to configure the clock of your microcontroller. So generally microcontrollers have an external clock through which they have to be referenced. So first of all, you will need to download this data sheet, which is available on TI site. You just have to search for SLAU208M, okay, and then after you can click on the first link which comes. Then you just have to click whatever thing opens. This will be a PDF, okay. You just have to download it from here. I've already downloaded it. It looks something like this, okay. So you have to configure your clock first, and the software I'm using is Code Composer Studio. So it is a freeware, you can download it from internet, and you have to download it specifically for MSP. Now in the first line of the code, you just have to simply include a header file which will be of about MSP 430. It will have all the basic things you will need to program it, okay. Then we'll go and have a look at the data sheet, okay. And this is my data sheet about MSP. You can see there is a separate tab. There are certain contents in them, and a topic is there as Unified Clock System, UCS. You just have to go in there. Before we go to code the clock, I'll give you a brief about it. So basically your MSP has 3 clocks. The first is A clock, and then M clock and SM clock. A clock stands for auxiliary clock, M for master, and SM for submaster. Then you also have some software defined clocks which are DCO, digital controlled oscillator clock, and FLL is there. Yeah, this is the primary. So whatever signals you get from your XIN and AXA, which is the crystal you have attached, generally MSP takes crystals for XT2 in the range of 8 to 24 megahertz, and for XT1 it goes down to 32 kilohertz, that is maximum. So we'll be using mostly both of them, but mostly coding will be done on XT2, because you can bring that oscillator down from 12 megahertz say to something around 40-50 kilohertz, that I'll teach you how to do. So you can see like in the first diagram, when the first block you have XIN and the crystal, the data signal is coming, and it simply goes to the FLL, and that is your main. The second block which you see, that is the main block, okay. Now this, from the data from FLL, it goes to all the three the signal, basically it goes to all the 3 blocks. So this is my auxiliary clock, master clock, and submaster clock. So you have to activate this FLL block also, okay. Now we'll come to the coding part. So you just have to click on this and you go to registers. I told you this tutorials will use only register set coding, because using peripherals and all you can easily do them, but registers is a difficult thing to learn. So I'll focus mainly on registers. So UCS-CTL UCS-CTL1 and UCS-CTL2, they are mainly used to control DCO, which is the digital controlled oscillator, but we won't be going to that. We'll be using mainly XT2 to XT2, and through that we'll control all the clocks. So it starts on UCS-CTL3. So in here you can see there are 2 or 3 4 parameters, okay, mainly 4 parameters. And the first 9 bits, this is a 16-bit microcontroller, so you'll have to put 16 values in it. So 15 to 7, the 9 bits are 0, okay, and 6 to 4, this is a cell ref, and that will select this XT2, okay. Because in this series we'll be using XT2 as because it goes till 24 megahertz, so it will be helpful in doing UART communication and all, which will come in later part of this tutorial series. Now in this you just have to configure your clock. So now you have to give the value of these bits, these 3 bits, as 101. Okay, there is a simpler trick also. Now we'll come to the coding part. Okay, I'll just define a function as void configure clock. Okay, and again a main function will also come. Okay, in the main you will need to write one line to stop the watchdog timer. Okay, because that is a main line which is required in all the codes to stop the watchdog timer to avoid any software interrupt. Okay, that goes at wctl is equal to wdt plus hold. Okay, now this will be used to stop the watchdog timer. After that you have to call this configure clock, which will be used to configure your clock. I'm using the separate function so that in the later part of the series it will be easier for you to like remember which function is doing what. Okay, because you're handling a lot of intra registers, it will become confusing. Now we'll just write a while. Okay, now we'll go and define this void configure clock function. Okay, the first one was UCSCTL3. Okay, this is the add sign which I have given. Now you just go to the data sheet and you refer this. This is written as cell ref, correct? So you just have to write here in caps cell ref underscore and whatever number is there. So sorry, yeah. You just count 0, 1, 2, 3, 4, 5. This is the 5th number. So you just have to write cell ref 5. And you can add, and then one more configuration you have to do. Now these 2 bits, like the fields which are given, you can ignore them because they are reserved. Okay, and the second thing which you need to configure is the FLL ref diff. Like, see how it works exactly is, first you have selected xt2 as your clock source, and now whatever clock frequency you are getting, you select to what divisor you want to divide it. Like if you have 12 megahertz say, and you are using the value of 000, then you will get 12 megahertz as an output to all the ACLK, SMCLK and MCLK. But if you use say this like 0, 1, 2, 3, it is 4, you write FLL ref def 4, so it will come as 1 megahertz because it will be 12 divided by 12, so that gives you 1 megahertz. Okay, I'll be going with a maximum of 1, so I'll just write FLL ref def and 0 because I need the maximum frequency to operate. Okay, now we'll go to the another register which is uses CTL4. Now in this you have to select like your auxiliary clock, your sub master clock and your master clock, like which source they should be connected to. Okay, and you can see it in the block diagram how it is connected, and through here you have to select which to which it should be connected to. So all of it should be connected to xt2. Okay, so you just write SELA and then xt2 is 5, obviously 0, 1, 2, 3, 4, 5. Okay, cell A5 plus cells 5 plus cell M5. Okay, so I'll just show you UCSC cell A, which is, it all should be in caps. Cell A is for selecting the auxiliary clock. Okay, and then we'll go to cell S, which is for controlling the sub master clock, and we have cell M also we for configure the master clock. You can have different values also, it doesn't matters. Like you can have cell A selected to xt1. For this you will need to have it connected to S, so you need to write cell A is 0. Okay, so this is connected to xt1 and this is connected to xt2. Okay, now we'll move to the another register UCSCTL5. We'll see what is in there. Okay, now UCSCTL5 It is for controlling like the division factor, like if you want to reduce the clock speed. Okay, so when you say you have 12 megahertz coming from your FLL and going to your ACLK, now you can select what output from ACLK should be coming. Okay, now say you have 12 megahertz as an input, and but you need somewhere around 3 megahertz. Okay, so you need to set the value of div A as 2. Okay, so you just simply need to write div A 2. Okay, so we'll write it div A 2, sorry, yeah, and I'll leave the master clock and some master clock at its maximum value, like the maximum clock frequency to which it can operate, which is coming from your XT1 or XT2, like the second crystal oscillator which you have attached to your board. So 0, and so you have your sub master clock to its maximum and div master clock also to your maximum, but you have reduced auxiliary clock speed as according to your need. Okay, it depends on your need and the requirements. Now we'll go to UCS CTL C6 and just we'll write it UCS CTL 6. Okay, I'll just check. Yeah, you'll say now XT2, you were working on XT2, so you say you're having a 12 megahertz oscillator. Okay, so it will be set at 0 1, so you need to write XT2 drive and 1, XT2 drive 1. Okay, you'll see some other settings. XT2 bypass. Yeah, actually now you have your XT2 coming from some external crystal, correct? Because this is something which is connected from outside, so you just need to put XT2 bypass as 0. Okay, you even if you don't do it, it doesn't matter actually, because 0 is the default value. XT2 bypass as 0, sorry. Then we'll go to XT2 off. No, you don't need XT2 off, you need it to be on, but if you do it 1, then your XT2 should be off, will be off. So if you see the description here, it can be shown that it is 0, then your XT2 is actually on. Okay, so you just we leave that for now. Okay, I'll show you how to operate it. Actually you need to use your OR AND gate. Like if you want to set a particular bit to 0, then you need to multiply it with 0, because if you keep it adding with 1, it won't operate. Like 0 plus 1 gives 1, but you need 0 in place of that. That's why I'll just write, and I'll put here whatever code was here, it was XT2 off, correct? And XT2 off is considered as 1, so I'll just write the negation of XT2 off. Cool. Now I'll just put a semicolon, and we'll see some other things. You don't have to work on XT1, so you just leave XT1. XT2 is already set. Now XT1 you don't async clock. Yeah, you actually need the async clock also, so it has to be on. Again, it has to be left on. Okay, so you again need to put that on and thing on here also, so I'll just add it to here. Okay, it goes something like again or async clock off. Cool. Now this thing was done already. Yeah, so you have your clock configured. Now we'll go to UCCTL7. I don't think there is any use to it. Yeah, there's. Yeah, I think we're done. We'll again check one thing. Yeah, you also need to add a do while loop to check whether some errors are present or not. Okay, you just simply have to go there and write a do while loop. Okay, it works something like this. Like you have to check UCS CTL7 in that. I'm so sorry. UCS CTL7. And you have to put and again you have to turn off some things. Okay, and just put it. These lines are common for all clock. You just only changes you need is to do in these few lines when you need to change the value of clock. Okay, then these lines will remain common. And again, UC CTO 7, you need to turn on the XT2. Just a minute. And one more line comes. This is to clear the interrupt flag. So not interrupt flag or which belongs to the special function registers. Yeah, this was a do-while loop, as I told you. This is basically used to clear the and reset the SFR registers. Okay. We'll just see what these registers mean. Okay, I'll just go to the data sheet and show you. Yeah, going to the data sheet, usage CTL 7 we were changing. Now see, what we did was in usage here we just negated with the AND operator XT2. Let's see what it's is an occur. Yeah, this is the check whether a fault is present in XT2 XT1. Okay, you can see I check for XT1 also and for DCO also. That's why I told you these line will remain common in all the codes. Only changes you have to make will be in these lines. Okay, now after this whatever board you are attaching to, you just have to run the code from project and build project. Okay, and this code will start running in your PC. Now in the next tutorial I'll teach you on how to blink a LED using the timers, like not using some delay and all, like using the timer compare mode of the MSP microprocessors. Okay, so thank you.